Good morning, everyone. Welcome to XA Talk Show. And today is okay. I need to get these correct. Today is let's talk about stuff. Then, okay, stuff. XA Talk Show. Put the title correct, and we're gonna talk about Golan and stuff. And let me So yesterday someone asked me about my opinion about dynamic typed languages versus statically typed languages, and I kind of babbled for 30 minutes. But here's the thing. Okay, so in summary, it's in summary. Okay, dynamic languages are actually easier to use for prototyping and stuff. They are faster. And I was watching a video talk by the Ryan Dahl, the guy who created Node.js. I admire him very much. He's a mathematician, and he's a very great programmer. And he mentioned that dynamic languages actually for scientific computing. For example, if you are kind of data scientist, or data scientist is like a fashionable term in the past five or so years. And data scientist, I've been drinking this shit for like the past 5 or 6 years every day. This is like Red Bull, but it's some kind of a cheaper version. It does you. So anyway, if you're gonna drink that, never drink the sugared version. Never drink any of those sugared. Like I never drink Coke or sugared water, Coke, Pepsi, and Sprite and stuff. 7 Up. This is 100% grape juice, by the way. I mix them together. But anyway, so I've been drinking these, energy drinks for like every day for past 5 years, 6 years, and for several years I was drinking the sugared one. But actually, in my life I never drank sugared stuff. But so I was drinking the sugared one, and it does your body no good. You start to get cellulose, on your thigh, or wrinkled skin, fat. So I stopped drinking that. So even drinking the energy drink, I'm not sure it's a good. I mean, it's probably not a good thing. But if you do drink, I mean, just don't ever drink sugar. Okay, don't drink sugar drink, Pepsi, Coke, and whatever. And in fact, don't put sugar in your coffee. I never put sugar in my coffee. Like, don't. Sugar is just no good for you. Period. Okay, don't eat sugar. But anyway, here's to mathematics. So we got one guy watching. Say hi. Type in the comments here. Say hi here. And so I was talking about yesterday. I was doing talking about dynamic typed languages versus statically typed. Hey Norman, great to see you. Two guys watching now. How is that? You and me. So and I babbled for 30 minutes, but the gist is that the gist about dynamic versus static is that Ryan Dahl, the guy who created JavaScript, Node.js, he mentioned that if you are doing scientific computing, basically you want to use dynamic languages, because static type languages, even with type inference, they just you actually have to do a lot, some more work, just basically, I've been doing Golang in the past year, and I've been doing JavaScript, for many years, and Python. So I like Golang very much, but but I noticed that whenever whenever I want to compute something simply, just realize Golang, like when you start a Golang, let's see, Golang. Okay, this is my quick way to start Golang. So you can see Go 3. Okay, Go. Okay, you see, first of all, you need this template. Even though it's simple for me to type it because I have set up a briefs and everything, but that's the first thing you need to do. You need the package, you need to import fmt, which is for the print statement, which is essential. So anyway, in short, when you are doing any type of scientific computing or even Mathematica, for example, Mathematica is not typed. It's like Lisp. You don't the typed languages does you it's cumbersome to actually. Okay, so that's what Ryan Dahl said. I agree. When you are actually doing typed computing, I mean the scientific computation, you don't want typed languages. Because I was thinking, or at least you guys, any of the typed language fans such as Haskell, I mean, you have the thought that you love it so much. You think type inference and techniques and function composition can be extremely short, very expressive. You might think all these other advantages will actually blow away, will make you code faster. I don't think that's actually true. For example, OCaml is also a strongly typed language with type inference. So anyway, dynamic languages are generally better for prototyping quick stuff. But okay, back to my opinion about dynamic versus static typed. So yeah, in summary, dynamic languages still good. I still love them. Lisp, JavaScript, for example, Python. Although I don't like Python and JavaScript, but anyway, but the other point of view I very much are into now in the past 5 years is that strongly typed languages such as Haskell, if you view this programming language as a logical system, such as doing math proofs like COG. There's a programming language. It's called proof system, math proof system, COQ. Then you want types, because type theory is one of the major foundation of mathematics for doing proofs. Therefore, if you view Haskell or similar languages as a proof system, as a logic system, computational, computable logic system, then you actually want very strongly typed. Why? Because then those types becomes, that's the main dish. I mean, that's what that's the meat. Before when you're doing computation, like scientific computation calculations, find a solution to a matrix or plot a math surface, you don't need types. Types are like a byproduct of computer engineering. I mean, they are there because the compiler writers need to have those to make it fast. Otherwise it's dog slow. So it's a byproduct of computer engineering. But if you are doing proofs like a logical system or verifiable program software, or if you are doing foundation of math, then you want types, that, because that's the meat. That is what you actually want to use. I mean, you cannot do math proofs without types, because you are doing type theory essentially. So that was like the summary of my yesterday's half an hour babbling. So there's no ultimate answer even for me as to which one would you pick. If I can pick only one language, typed or untyped, I can say, because normally every day, I want untyped, I want dynamic languages, but I'm very interested to study about proof systems, logic system, the foundation of math, automated proof systems by computer, and that type is like the heart of it. So so that was about yesterday. So we got 5 people here. So say hi, guys. Say hi. So that was kind of a summary of yesterday's rambling. And today we're gonna do, let's see, XR Talk Show. Today we're gonna do here's to health. How's it going, Norman? So it is a 7 o'clock, 7:40 in your location, right? East Coast. So I think we're gonna do Golang. I'm gonna start to do Golang. I can do lots of things. Sometimes, we haven't been doing a random chat for a while. Random meaning like non-technical. Like I talk about what's happening, and sometimes we can inject some technical stuff like Emacs, but like lots of things. YouTube, I wanted to talk about that for a while, but so we haven't had a non-technical talk show, so-called talk show, talk show. But also, I need you guys to type to let me know, because so the more conversational you guys going, then I see it, and then it becomes more fun. But I also realize, I cannot just rely on people, chatting, because many people, I suppose, you don't want to, type. It's like, you just want to listen, whatever. So actually, I'm going to start to talk about, I think, Golang. Okay, so let's see. This is my Emacs. Let's see where. Okay, here is today. Okay, so we discussed typed versus summary of typed versus dynamic, and let's get rid of that. And okay, teach Golang. Yeah, let's do that. Then okay, so I'm going to go to my Golang tutorial. Let's view in browser. Let's go Golang tutorial, and so I've been, I mentioned this before. I've been walking around with my Surface Book. Surface Book. Well, this is actually not Surface Book. This is called Surface Pro. So so I walk around and taking notes, and there are some things I need to correct. But actually, let's begin to do the Golang, because I'm doing videos. I learned a lot. I'm trying. So one thing I want to improve is to kind of like condense what you want to say, instead of sitting there and so I can condense, get not avoid empty videos, like people wait for me to do things. So Golang, we talked about it yesterday. So you just download Golang and you can run it. But today, let's start by let's do this. So I'm going to start to code a small problem. Golang. Let's see, where is it? Some talk show. So let's do it here. So let's just add. Okay, let me show you the. So add the tag for Golang, and just pop it out, and we can start to type Golang. Go. Okay, and what I want to do is to write a program that prints the first 100 prime numbers. Okay, so let's begin. So we run this. This is just 33. So oh my god, this is going to be a task. Do you like Go error handling? No. So so Norman, do you have some experience with Golang? Looks like. Some people prefer exceptions. Oh, I don't like exceptions. Oh, for heaven's sake, no exceptions. However, the Golang error handling is very tedious, cumbersome. It's like every 10 lines in your code, you're gonna have a catch error. Let's see. Yeah, great. Sorry, exceptions. Exceptions is the worst thing in computing industry. In programming languages, it's one of the worst. Okay, so I looked into this topic a few years ago. So I wrote a essay, and first of all, okay, this guy says exceptions. They are one of those most complex and ridiculous thing ever devised. I concur. Jonathan Blow. I forgot what he does, but he's a. This is from a YouTube talk he's given. I think he's a D. Yeah, he's a language D, one of the language D creator, or the major guy. I think I forgot. Yeah, but also okay. So let me talk about exceptions maybe a little bit. Yeah, so you know um, you guys ask me questions. I go into that topic. We get back to Golan soon. So exceptions. First of all, note that what you guys, what you know of exception is actually may not actually be what it is, because exceptions typically, okay, you have exceptions in Java, in Python, in JavaScript. Okay, for example, those exceptions are pretty much similar. Okay, but however, the history of exception of the jargon exception is entirely different, and exceptions in other languages is entirely different. Okay, they are not. They are totally they are completely different concepts. So if you are one of the people from Python or Java or JavaScript, you might think, okay, you might think, okay, I like exceptions or I don't like it, but note that other people's concept of exceptions is actually entirely different. Your concept of exceptions, yeah, is actually just one, one small, well, not small, but because there are a lot of Java coders in Python, your concept of exception is only one of them. Okay, and also your concept of exceptions in Java, Python, they are entirely different from the history of exceptions. Okay, the history of exceptions, actually it came from Lisp. Everything came from Lisp. However, the exceptions in Lisp is totally different from whatever Python, Java. Okay, it's not that at all. I'm not gonna go into details about that, but anyway, well, you can read this article if you like. Then many of this information are from Wikipedia. So you can read about it in detail. So anyway, so first, let me just give you a few summaries. First of all, exceptions may not be what you think. Okay, your concept of exceptions, that's just your concept. Okay, well, let me. I actually have a summary here. Let me read it. Programming languages differ substantially in their notion of what is an exception. Okay, your notion of exception in Python, Java are totally different from other languages. Okay, then exceptions in most imperative languages such as Java, Python, JavaScript is a form of goto. Yeah, that's a good point. so in Python or Java, your concept. What does the exception do? They are actually just goto, the goto statement. But they are like implicit goto. I mean, when you have a goto statement, I mean you tell your program to exit the loop or go to some other part in your program and start from there. That's goto. Okay, you have goto in Perl. You have goto in these days not many languages have goto. Well, you have some form of goto in Emacs Lisp. Let's show it then. Xali Emacs Lisp exit loop. Yeah, catch throw. Here is the you see. So remember exceptions. You usually have the catch throw thing. Catch and throw. Emacs Lisp also has that, but Emacs Lisp is catch throw is entirely different from your catch throw in Python or Java. Okay, in Emacs Lisp you have throw and catch. They have nothing to do with exceptions. Well, they are like Lisp's original kind of related to original concept of exceptions. But anyway, throw and catch, they are just go-to in Emacs Lisp. Okay, when you throw something, you put a name, a tag, then the program will find somewhere else in your code that has the tag catch. Then it'll just jump the program, start from there. That is basically it. So it's a go-to. It's just a go-to statement. There's no implicit, error exceptions that's hidden somewhere. I mean, everything about the throw and catch is like just in your code. There's no hidden exception, file error exception or something like that. It's not like that. So at least you have catch and throw. And okay, so let's back to the summary. So it's a form. Exceptions in Java, Python, JavaScript. They are a form of goto. They are implicit goto. Okay, and for that reason, it's pretty bad because as you know, good proper programming, you usually don't want implicit stuff. You want everything explicit. Okay, and then in some languages, exception is just a syntactic form of goto, and that is all. Yeah. For example, like Emacs Lisp, the throw catch is just goto with a different name. That's all. Then in some languages such as Java, Python, exception is more than just goto, but goto with a tree of gotos, which runs out of your control. Exactly. You can simply throw or simply try, and the language will do things in the magic realm. That is true for Python. Jesus, I truly despise Python in every aspect. So in Python you have like you try something and you throw or you catch. But what happens? Because basically you have a hierarchy of gotos underneath it. Not in your program, not in your source code, but the language has a tree, like a hierarchy of gotos. Exceptions. So this exception's parents is like exception that parent. So it's very bad. Then this item, Google's new language Golang does not have exceptions because the designers consider exceptions harmful. Yeah, because if you go to Google Golang's blog, you'll find this. I have a link here, Golang FAQ. They discuss why they do not have exceptions in Golang. Basically, Rob Pike and I think Thomas. The inventor of Golang, they decided, not they decided, but their opinion is simply that exception is just bad. It's a bad feature in programming languages. So they give a reason, Now, last item of summary. If you don't like typical notion of exceptions in C++, Java, or Python, be cheered that many well-known expert programmers do not like them neither, and never use such features in their own code. Yeah, that applies to me. I never ever liked exceptions, and I never ever used them once in my 20 years or 30 years of coding. I never used them once. Not in Python, not in Java. Well, I haven't really coded Java that much. But yeah, I don't use them. I didn't use them. I mean, I wrote this article back in 2014, but all the 20 years before, I never used them because I find them extremely convoluted and hard to understand. You don't know what's going on. I like functional programming. Basically, every program I wrote is functional programming. I don't like OOP, but in Java, uh, in Python, you can still do functional programming without ever using OOP. You kind of can. I at least I do that. But in Java, for example, Java is simply a OOP language. You cannot not do OOP because everything is a class and object. Uh, yeah. Okay. Yeah. So here's about exceptions. Now. Okay. So I go into details about exceptions. This the semi-predicate problem, uh, and the solution to semi-predicate problem. What is a semi-predicate problem? The term semi-predicate problem, the term captures the problem I had for a long time, namely when a function returns a value but the function might encounter a error. Oh, right, I see. For example, invalid input. How do you signify that error? Yeah. So that's one of the issues related to exceptions, and there are several solutions. In the history of uh, computing, we have several solutions to the semi-predicate problem. Yeah, exception is not only bad, but also programmers don't understand it. I mean, if you look at all the code in the industry, many of them just use them incorrectly, and many of them use it just as laziness to to avoid doing anything. And here's a history of exceptions. Okay, so anyway, and there's a video. What is this video? Jonathan below. Okay. Oh, and Haskell. Okay, Haskell also have exceptions. This guy Yuri Khan. He's a acquaintance. He's also a Emac, heavy Emac Lisp user. I think he also code Emac Lisp. Yeah, I think he does, but I'm not sure. I don't know if he wrote any packages. But anyway, he has been commenting on my website for a long time, for many years, and his comment always comes through to be the best comment, the high quality. Like usually when I have some opinions, okay, for example about exceptions, then you get a bunch of idiots like I like exceptions because they don't know nothing. They never studied the problem. They don't know nothing about mathematics. They don't know nothing, like zero, about theoretical computer science. They do not know anything about history of programming languages. What they know is like they are just average programmers, like the hacker types. They average programmer. They have some experience, 5 years of programming in different languages. Then they have opinion. Then they're gonna tell you, I like exception. You are wrong because this is that. But they don't understand what it is, and then the bottom line is that they never actually spend dedicated time like to study some issue. They just throw their opinions, and of course they say, "Oh, you don't understand Python, you don't know Python, or you don't understand this that." So most comments are like that. But this guy Yuri Khan, I think he's from Russia, or some Russia. Yuri Khan, so he knows a lot. So every time he comments, he usually answers. Sometimes I have a question, he answers my question, exactly the way I ask. Because in my life, oftentimes I have questions. Of course I do, about programming languages or mathematics, lots of things. But usually when I ask them, the response you get is that, okay, you have lots of these, ignorant people. But if we exclude those, then sometimes you got mathematicians, who actually, know things, but but they don't understand your question. Like they dismiss it. Like they saw it, and then they give you an answer that is like FAQ, frequently asked question. That they are not answering your question. They don't see the question. Uh, because you know for mathematicians there are exceptions. For example, the um, John Bayes guy, he is a great, he always see my questions and answer to my to really helpful to like my questions are usually not the frequently asked questions, because I looked at things, I study things, then I find a question. Those questions are usually you cannot find answers, because they are kind of okay. Anyway, so Yuri Khan guy is very great, knowledgeable, and he's also he's on Emac dev list. You can see his post there, but he's also knowledgeable about Python. He's a fan of Python. Okay, so we disagree on that. And he is also, I believe, he's an expert of Haskell. So he give a explanation about how exception works in Haskell. Now I don't know Haskell, so I learned that I learned things from him. So he give so Haskell is exceptions in Haskell is of course entirely different from your Java, Python, and so on. Okay, that's about exceptions. Now back to Golang. Now so Golang, they don't have exceptions. So how do they handle the semi-predicate problem? They handle it by let's see. Basically, they have errors. Let's see. Well, basically, what they do is that the primary way they solve the exception problem is error handling. Is that a function returns can return more than one value. It's called multi return. So let's go to function. So here is Golang, and hold on a second. Let me maybe let's see if I can. Yeah, okay, so here is good. Golang, so this is Golang, how you define a function. And okay, so you define a function func ff parameters and the type, and then the return type you put it here. Then you begin the function body, okay, here. But okay, multiple return types. So here is how Golang handles error. To indicate that the function cannot compute, it's an error. It returns multiple values like this. You can just return multiple values. Then, return multiple values. Then when you want to get the value, all you have to do is assign it to to multiple values like this. For example, we define the function here, ff, xy as input, and it returns x and y, two values. It just returns the argument, two values. So it's not a list. It actually returns two values. But how do you get those two values? You just assign them to a variable with two variables. That's how you do it. So so function return two values. Now, when you have a function that, say, for example, possibly you'll get an error. For example, xy, and you want to divide x by y. So if y is 0, it's an error, right? But you want to indicate, y cannot be 0. If y is 0, you want to tell the coder, something is wrong. So you just return two values. The first value is the answer. The second value is the error. That's how you do it. You just have the function, the second value is the error. So whoever calls the function can just check the second value to see if it's error or not. So that's how you do it. Let's see. Okay, so let me show an example. But before we do that, let me read the comments. Hey Nicholas, greetings from from Hong Kong. So two guys now. Do you like Golang error handling? I have very light experience with Go. Learning it. Okay, great. Exceptions are a fancy go-to and have some of the same problems. Yes. Erlang has a very limited form of exceptions, mostly used for non-local returns and propagating process exit. Cool. Yeah, I never learned Golang, Erlang. I like to, but I just never got to. Yeah, Erlang. Yeah, Erlang is interesting. Okay, so let me show you an example of Golang's, the error handling. It's very annoying. For one thing, I love it that Golang don't do exceptions. Great, it's wonderful. But however, Golang has it so happens, it turns out, you have to do a lot error code handling, like every 10 lines. Every 10 lines, your function will return the second value, as an error indication. Then you have to check that value. So it's kind of annoying. But however, still, I don't want exceptions. Okay, I rather, this is still better than exceptions. So let's just go to let me show you a exception problem. Okay, so here's my program. What does it do? It does find and replace. Let me show you an example then. A new buffer. So let's go to my Emacs blog. Let's go to the diet directory. Let's go up a directory. Okay, let's look at Emacs manual. Let's look at Emacs Lisp manual. So I copy the path and close the window. So so this is a Golang script for doing find replace. You can see the code here on this website. Let's go to the website. And you see this is it's like 200 lines. It does find and replace with a bunch of features. It can do a whole directory, including nested directories. It can filter out files by file extension or using regular expression. It can take a list of files instead of directory. So if you just only have a list of files you want to process, you can do that. It will auto do backup if you want. It can have multiple find replace pairs. So if you want to do find replace on multiple pairs, you can do it one shot. So these are the features of this Golang script, and I'm going to give you a demo of that. So first, to use this program, you just open the file and change the parameters in the beginning. For example, here. Okay, so this is the input directory. File name rejects is .html. All HTML files. Write to file true. No, I want to false. Don't write to file because that's my Emacs manual. And do backup true, backup suffix true. Okay, and then find replace pairs. So let's replace all Emacs Lisp by Haskell. Okay, let's do that. And I just run the code. Let's there are like 1,000 files, so run it. Write to file is false. Done. Okay. So that, well, basically it says there's no replacement. That cannot be true. So basically it says it does not find any. Let's try to search for it. Oh, so the entire Emacs Lisp manual does not contain the word Emacs Lisp. That cannot be true. Oh, okay, I know why. Wait. Because the capitalization, yeah, I think so. So capitalize, okay? Let's do it again. Yeah, there we go. So there are like 900 files changed. Actually, they are not saved because I have write to file false. But you can see otherwise, 900 files are changed. Emac list is replaced by Haskell. So that's how this program works. And okay, so now I'm going to show you where the error handling it's pretty it's everywhere. Like every 10 lines you'll see it. For example, this function do file, okay? So this function do file is just open the file and open the file, read the contents, and do find replace and save it. So that is this function, do file. And okay, it's okay, it's like 20 lines. And then this function takes a path, file path, and returns an error. Okay, it returns nothing but error, so it just returns error. So okay, so let's look at the code to do file. Let's okay, actually I don't have any code that checks but okay, let's forget about that one. Let's look at this one. IOUTL, read file. So this is when you want to read a file into a text. So read file takes a file path and returns two things. One is the content in bytes, file content, and it returns an error. So the this read file is from the IOUTL built-in library. So it's very common. In Golan's libraries, it's common, very common. Almost every function returns two things. The second thing is error. So here's an example. So once you do that, then you have to check the error. You see this line? If error is not nil, then you have to do something. You see, you print. So if there's an error, I want to print out what path I'm currently processing. And panic. Panic just means exit, So that's an example of error. Error handling, but you'll see this in a lot. For example, let's search for error. So there's one, there's another one you see here. Rename file. I'm trying to do backup here, so there's rename file function. It also returns the error, and you have to check the error, because if you don't have the code to check the error, Go compiler will complain. I think it will. For example, if we delete this line, let's delete it and let's run it. You see, okay, error declaration not used. Because I declared the error here, so yeah, but then we can try to remove that and see what happens. But we can try that. Let me do a backup. Okay, let's run it. Okay, it still runs. Okay, yeah. So for this case, you can skip the error checking. But basically, yeah, basically, Golang kind of like wants you to always have errors. I mean, in real life, you have to do this a lot, because otherwise compiler will complain. So that's one of the problem, of Golang. You have, that is kind of tedious. You have to, every 10 lines you have to check error, and panic. Here's another one. For example, this one, like when you do a rejects, okay, rejects match string, it also has to return the error. And if you do not catch the error, I mean, if you don't check the error, let's see a complaint. Yeah, it complains. Well, but anyway, so that that's a issue. So let me read the comments. Hey Danielle, but I have to go. So remember, people, all command keys can be changed. JK, what do you mean? Norman says. Norman says, in my C code, I sometimes wrap explicit error checks in a macro to reduce the checking clutter. Oh, I see. So in C support macro. I know C++ supports some kind of macro, but I never programmed in C++, so I don't really understand. I don't really know what uh, how. I think they call it preprocessor. Is that preprocessor? Basically, when the compiler reads your source code, it first, I think it does a find and replace on your source code. In the beginning of your source code, you can define some kind of find and replace, and the compiler read it. It does do the find and replace. Then you'll start to compile. I think that's a gist, right? C processor. Okay, so that's about the exceptions. I'm wondering. Okay, so 46 minutes. I think we can continue back to Golang. Yeah, let's hold on a second. Let me make sure my program still runs. It does. That's good. Close it. Close it. So I think let's go back to print the first 100 prime numbers. Maybe we can do that. We have 15 minutes. But okay, so we have 8 people watching. Guys, say hi. Say something, in a comment. Just type anything. Like you can type which country, which country coming from Singapore, coming from China, Beijing, coming from United Kingdom, or coming from Russia. Well, let's do the Golang then. Let's do. Yeah, so I'm going to print the first 100 prime numbers. Let's see if we can do that. So first of all, every Go program you kind of have to have this kind of template. Okay, that basically every Go file. So how do we do it? So print. We're gonna use the prime sieve method. So let me do it. So what is square root of 10? Okay, 10. Okay, how do you do it? How do you do it? We can look up Wikipedia, but let's try not to do that because this should be simple. We want to use sieve method. Sieve method. So 1 to 100. So let's say so I want to print the first 100 primes. Now, okay, let's just say I want to print the first the prime numbers within 100. So basically, you start with okay, you go through 1, 2, 3, 4, 5 for each number. You multiply it by 1 plus 1, 1 plus 2. Wait, okay, let's start from 3, for example. 3 times 3 times 1, 3 times 2, 3 times 3, 3 times 4. Okay, each one's got a result. And for any of those results, you cross them out, in your list of 1 to 100. That is the basic, that's basically the outline of the algorithm. then you, at the end, you just look at your numbers, your list from 1 to 100, and see which one are not crossed out. Those are primes. Yeah, it sounds simple, but now we begin to code it. So, so first of all, I'm probably gonna write a bad program, but the goal is to do it. So let's just do it. Let's not pay too much attention about elegance and efficiency. So first of all, I want a list of numbers. Oh my God, How do you get the list of numbers in Golang? So um wait, how do you get the list of number in Golang? Slice. What? This is impossible. Okay, the other thing I remembered about Golang is that it's kind of it does not have many functions. Like for many functions, you just have to write your own. For example, I remember there's no function for minimum. Like if you have a list, you want to get the minimum. You want to get the element that's the smallest number. There is no such function. You have to write it yourself. Match any, find, replace, random number, defer, pointer, system call. God, this is pretty bad. Now I want to wait. Okay, let me think. You want to get the range of numbers. What? There's no. I don't remember. I don't remember. There's a range function. Okay. Well, normally if I'm coding, I just go. I just Golang range, and Stack Overflow will come up. Okay. Golang wiki range. Map of integer to record which are marked. What do you mean? Map of integer to integer. Okay, let's just start to write it then. Let's just use a for loop. For loop, let's say I to 100, okay? And for each thing, we want to i's begin with 1, and let's say print, okay, I, okay, and for each okay, size, okay, plist, int. So plist is a slice, which is like an array but extensible. The length can change. So this will be our final result. And first of all, push. Wait. So I want to fill the list with 1 to 100. I don't think there's a range function, and I don't want to look at Stack Overflows. So let's go to loop, not loop, but slice. So slice, okay, so 0 from 0 to 100, and I, so plist I equals to I minus 1, okay, and formatted expected expression. Okay, this is wrong. Plist, okay, that's a slice. It should be right. Oh yeah, so yeah, so you just want declaration, you don't have values yet, so this declares that plist is a slice. Okay, so formatted, that works, and run it. import not used. Okay, yeah, Golang has lots of these kind of annoyances because when you import a package and if you don't use it, it'll complain. So when you are doing prototyping, you have lots of these annoyances because import you're gonna use it like eventually, but you cannot just leave it there yet. So we're gonna print plist. Okay, run it. Okay, runtime error, index out of range. Um, Index out of range. So plist one. Oh, this will be +1. Runtime error, index out of range. What? Okay, I is 0 to 100. 0 to 100, and why can't it work? Okay, how do you assign print slice, length of slice? Let's okay, this is not good. This is going bad because I haven't been coding Golang for like 3 months. 3 months. In order to do this, I should have practiced it for a week because you know uh so wait, so what we gonna do, so what are we, okay, so we are trying to find out why the index out of range. Why should the index be out of range? uh oh, you need to use append. You cannot assign it. Let's see, array. So here is array, so here is how you assign array elements. That should work. Let's try that. Okay, this is getting stupid. Okay, even here it's wrong. um, okay, so this is that's good. Nine, 4, 5. Okay, that works. Okay, yeah, this is not going well. I'm even just trying to get a range of numbers and it's taking too long. So I think that's too bad. I think that would be it. Well, maybe just should I continue? Um, we still have 8 people watching. Um, yeah, we should. You see, the problem right now is like I the problem is I forgot the basics. You need to be fluent with it in order to actually do this in real time. Otherwise, you're just gonna look at me struggling with the syntax and stuff. Uh, the problem here is now I have a plist which is a initialized to which is a type slice of int, which is and the first three elements are 3, 4, 5. Then you assign the index 0 to 9, so that works. Then let's so this works, 9, 4, 5. But if you add this, it does not work because exit status. Well, that's the reason is because let's say exit status 2 because index out of range. So because you are for example, let's say print print length plist. So length is 3. Then if you do this, that works. That doesn't work. Yeah, so you cannot assign an index that's not the next available slot. 2. Yeah, this works. Then you can do 3. Oh, you cannot because wait, this is wrong. Array we have a slice here. Now slice the slots, the number of elements in slice, they usually okay, I think I know why. You cannot, in order to do that, you have to use append. You cannot just add, extra elements there like that. You have to use append. So let's do that then. So append I now this is very inefficient because append returns a new slice every time. So what we are doing here is actually returning this is very inefficient, but it works, because append returns a new slice every time. So every time you add a new element to the slice, it actually creates a new slice. I think it's very inefficient. Should we do another way? Or but another way. Well, let's forget about efficiency. Let's just pressing on with the prime numbers. So, okay, now we have a number from 1 to 0 to 99. Actually, we want 1 to 100. Yeah. So now we got the plist. Now we have to start with 2 to yeah, let's just let's 2, okay, 4 I equals to 2 to 100. Okay, so Norman says I was thinking something like map int. Oh, that's key value pairs, right? So do you do your loop and make num primes, then zero values in the map are your primes. That makes sense. Yeah, that's a good approach actually. Yeah, that's yeah, we should do that. Um, well, but we already begin this path, so maybe we just keep pressing on here. Um, yeah, so right now I want to do 2 multiplied by 1 to max. So um, for 1 to max, if 2 times I is in is 2 times I this is so bad. I'm wondering if I should continue because okay, actually, to actually do it, there's a Chinese saying that if you make haste, you're gonna be slower. So if I'm gonna actually do this, I have to like think, instead of just start, instead of banging on keyboards, I actually have to, take 5 minutes to think about exactly what, think about the algorithm. At least that's my style of coding. I spend 5 minutes to think about exactly the algorithm, what I needs to be done. Then I start to code. Then you have an idea. You want to use, what kind of loop or map or data structures or map, hash table or a slice. Then you implement, your plan. So yeah, maybe we just let me talk about, I'm not sure I'm gonna, this is not going well. So but let me just talk about them. What am I going to do? So we want, first of all, actually the problem, is the first 100 prime numbers. But to simplify that, let's begin with, just list the prime numbers that's under 100. That's probably we can do that first. So all prime numbers 100. So we want 1 to 100. Then we start with each number. Each number, let's take for example 3. Then you multiply 3 by 1. Then multiply 3 by 2. It's 6. So you got numbers like 3, 6, 9, 12, 15, 18. and for each one you want to push it to a list. For example, there's concerns about efficiency, but let's forget about that for now. Let's just we don't care about that for now. So anyway, so for the start, for example, number 3, we multiply it by 1, by 2, by 3, and so on, and until, let's say, until 100. 3 times 100. Yeah, let's not care about efficiency for now. Then for each result, we can push it to a list. For example, let's just push it to a list. Okay, then we do that for the number 4. Yeah, this way it's getting extremely inefficient. We do the same for number 4. We do the same for number 5. Like 5 times 1 times 2 times 3 and so on, and put the result into this big list of except the number 5 itself. Okay, then we do it for number 6 except number 6 itself. So we start with 6 times 2, 6 times 3, 6 times 4, and so on, and put the result in a list. Then we begin with 7, and so on until we have at least 100. Then, okay, after all this done, you want to find out in your P list, which is 1 to 100, you want to find out which one is not in the existing list. Then those are prime numbers. That's your result. So you can do a not union, not intersection, but minus, this list minus that list, basically. Okay, so that's a very inefficient algorithm. We can, so the next step is that we can rethink and refine the algorithm, because there are a lot of inefficiencies, repetitions over there. Or we can just start to code it. Yeah, let's start to code it then, because since we are doing Golang, we want to show the Golang stuff. Okay, so we got a list. So we start with number 3. Okay, so we got the list. So num primes is the list. Okay, and we start with the number 2. Number 2, let's begin with number 2. Number 2 times, okay, so here's what we do. Start from 2 to num prime equals to 2 times 2 times I. That's right. So 2 times I. So num prime will append 2 times I. That's right. 2 times I start with 2. For each one, let's just do that. So that looks good. 264. Okay, that looks good. Let's try this for 3 again. So starting 3, 6. Wait. 3 times I. Oh, this should be 2. So beginning here, you can see it start with the the multiplication with 3, 6, 9, 12, 15. So we do this, then we do this for 4. That's right. So that is correct. Starting with 4, 8. Starting with 8. There it is. So these are the multipliers for 4. So that looks good. So now all we need to do is just a double loop, a nested loop. Okay, so we do that. 4, 0 to 100. Okay, 4, 2 to 100. Okay, for each one we want to, so J, J, J. This will be J. Does that look right? So we have a nested loop, and we don't need that anymore. Let's try it. Wow, a big one. Oh, this is an example where Emacs slow down, because if you have one huge line, Emacs becomes extremely slow. It's not due to Golang, but it's due to Emacs trying to display the huge line. It's pretty bad. So that's gonna go on for a while. Actually, kill it. Yes. So if I do not print it out, it's pretty fast. It's already done. You see? Yeah. So if we don't print it out, it's pretty fast. But okay, there are some. Now we want to put the num prime into the list num prime only if it already does not exist. Let's try to do that. So I mean, our algorithm so far is extremely inefficient, but let's not worry about that for now, because basically in real life, anything you do, in the beginning is going to be extremely inefficient. Then you're gonna refine it and refine it. So I haven't coded, C of prime since like 1991. So and the quick, the easiest solution is actually just go to Wikipedia, because they will tell you the proper efficient algorithm. Actually, there are more advanced optimizations, because I remember reading that a few months ago. But we don't want to do that, because the fun part is to work things out. You can see how we are thinking. I mean, this is an easy, simple problem. A good programming exercise when you learn a new language. So okay, so what? So let's solve this one problem. So we have two lists. We have one element. We want to find out, whether it's already in that list. If it is, don't add to it. Okay, this problem is actually easier done if we have a hash table, like a map. So let's switch to map then. Like Norman suggested. Yeah, so let's go to map. So maybe after we do map, after we create the map data structure, and let's call it a day, because this is in no way a good demo of Golang. Okay, so num prime, let's change num prime to a map, and the map declaration is map key type. Key type is int, and the value type will be true or false, right? Yeah, let's do true or false. So what is the type for true false? It's Boolean, but how do you spell it? So let's go to basic types. Run variable new basic types. Bool, okay, bool. So the value is int. The key is int. The value is bool. Now, how do you set value to a map? Create map with make. Okay, we don't care. Set value. Okay, it's like that. Then for num prime j equals to, oh, this is true. Let's run it. Num prime redeclared in this block. Okay, so comment that out, run it. Type map int bool is not an expression. Okay, yeah, that's right. So this actually should be, let's see, literal expression. Yeah, let's create an empty one. Okay, we can do it this way, or we can do it this way. This way you simply declare the var num prime to be a map. This way you actually create the initial value, in our case, which is empty, just empty map. So let's do it. Let's run it. It works great. So now we got a map. So now we can print num prime. Let's print it out. Great, we are getting better and better. Okay, so this is fantastic. So let's look at the map. So let's copy that, new buffer, magnify. Let's space to new line. Okay, so we got this. 27 is true. Oh, we need to, oh, it's not sorted. Let's try to sort it. That looks right, except, you know, you see 2 is over here, so you want to sort by first field. So let's call the command Control U1, then mx sort fields, sort numeric fields. Okay, that looks right. So 2, 3, 4, 5. No, this is not right, because 5 should wait. This is, no, this is wrong. This got every number. Okay, we yeah, something is wrong. 2, 3, 4, 5, 6, 7. Why is that? Oh, you should, oh yeah, it should be that. Stupid. Okay, so now it's printing a big number. So anyway, I think that's, I don't know if I should continue. Yeah, because it's now 1 hour and 20 minutes. I think this is no good. I'm not doing well here. Okay, let's optimize a little bit, because the way we are doing it is like 100 times 100. We got lots of numbers. Yeah, I hate people watching me. Yeah. Um. Okay, let's try a bit more. Oh, out of my energy drinks. I need my energy drinks. I need a drink. So this is extremely inefficient. That's not the way you do it. I mean, my algorithm so far, our algorithm is very bad, because you don't go over 100. So first of all, what is 100 square root? Square root of 100. So 10. That's 10, right? Uh, so let's think about the algorithm a little bit, because we don't want to add a huge bunch of numbers there, because we are only concerned about numbers within 100. So whenever, okay, one simple one simple solution is, if okay, wait, var x equals to cut. Okay, now that's the value. Okay, now if x less than 100, okay, max, let's say, if x is less than that, then we do that. So if x is less than max, that's right, max is 100, let's say max is 101, then we push it to num prime. Yeah, that would reduce the bunch of numbers vastly. That's good. Looks like so fast. Yes, before we are wasting a bunch of calculations. Okay, let's look at the result. Magnify, replace space by return. Okay, and we're gonna select that. Actually, let's just delete that. Then we're gonna select all, Control U to MX sort numeric fields. Oh, okay, so wait, let's do it again. Control U1, MX sort numeric fields. That's it. That's great. That is finally okay. Well, actually, we basically solved the problem, because these are the prime numbers. Yeah, that's it. 4, 6, 8, 9, 10. Wait, so 2 is a prime, 3 is a prime, 5, 7, 11 is a prime, correct? 17 is a prime, correct? 21, 22, 23, 23 is a prime, yes. Yeah, basically we solved the problem already. Okay, what? 2 more minutes, we'll be done. Oh shit, this is a success then. Let's try. Okay, first of all, this p list we don't want. Wait, no, okay. Yeah, we don't need the p list anymore. Make a backup. Actually, just let's just comment out. Then we just do a loop for 1 to 100. Okay, max. Then we just if I is not in the num prime, then we just print it out. Then we are done. Great. if I is not in okay, so how do you check if a key exists in a map? Get value, delete key. There, get value, mk returns two values. First value is a key, is the value of the key. Okay, the second value is true if the key exists, else false. So if m, okay, so m is non-prime. Okay, if that, okay, so here's what we do. AB, if B is true, if it exists, it returns true. So if B equals to false, okay, wait, if not B, then print. That's it. Print A. So I think that's it. Oops. Go format error. So wait. So what is the Boolean? Wait. Okay, so what is the Boolean to negate? Oh yeah, exponential. I mean the ban, exclamation. Undefined plist. Okay. Wait. Oh, if you want to print, oh, okay, so wait, if B is true, then don't do anything. If B is true, don't do anything. If B is false, print A. Print I. A declared not used. There's an issue with Golang. I mean, if you have a variable not used, declared but not used, you'll complain. So it's not very good for prototyping. There we have it. 97. So all prime numbers within 100. But now the problem originally is 100 prime, so we just increase it by 500. Let's see. We are doing cheating. So this is the first 97 primes here. Let's just increase it by 600. Perfect. Now we clean out the code. So now we spend like 1 hour to clean up the code. Then we show it to people, Then we say, look how beautiful it is. That's what happens on a Hacker News and online. You spend days and you clean up and show. Okay, we have the result. We have a program that prints the first 100 primes. Actually, we printed more, but we can, so there we have it. So okay, great. Thank you guys for watching. I hope that was a kind of not so good demo of Golang, but I hope you liked it. Thank you guys. I'll see you next time. Be sure to comment, okay? You can comment on my video YouTube video comments, or you can comment on Twitter, or just say something. Let me know what you want to watch next. And I'll get prepared for Golang, maybe another demo of Golang and stuff, or maybe we can do this in JavaScript. That would be fun, and also maybe in Python. So thank you, Norman and Nicholas. Hey, so see you guys. Bye.